All right, let's be real. Have you ever stared at a database just wishing you could ask it a question in plain English instead of having to wrestle with SQL? Yeah, we've all been there, right? Trying to translate some simple business request into a crazy, complex query. Well, what if I told you that you could? Today, that's exactly what we're going to do. We're going to build the magic that solves this exact problem. So look at this. On the left, you've got a super simple, intuitive question that anyone could ask. And on the right, that's the structured and, let's face it, sometimes pretty clunky SQL we have to write to get the answer. Our goal today is to bridge this massive gap. We want to make talking to our data feel as easy as just, well, having a conversation. So, in this tutorial, we're going to build an AI agent that does exactly that. And we'll be using a really powerful modern tech stack. Spring Boot for our backend, Google's Gemini AI to be our intelligent translator, and a simple H2 in-memory database just to hold our sample data. Okay, before we start writing any code, let's take a step back and look at the big picture. The high-level architecture. Understanding the flow of information first is absolutely key to seeing how all these different pieces are going to fit together. This diagram right here, this is basically the complete map of our system. It all kicks off when a user sends a request in natural language. From there, our Spring Boot app and Gemini work together to translate that into a nice structured object. And that object is then used to generate a dynamic and, most importantly, safe SQL query. Finally, boom, we get our filtered results back. It's a really clean, elegant flow when you see it all laid out. Okay, let's break that down a bit more. So first, the natural language request hits our Spring Boot controller. The controller then passes it off to what we're calling the Gemini agent service. You can think of this as the AI brain of our operation. Its job is to convert the plain text into a structured JSON object, which we call a DTO, or data transfer object. Then that DTO gets fed into a JPA specification, which is the magic piece that dynamically builds a safe query to go and fetch our results from the database. All right, enough talk. Let's get our hands dirty and dive into some code. We're going to start with the most fundamental pieces of our application, defining the data contract that's really going to control this entire system. So the very first question you're probably asking is, why do we even need this DTO, this data transfer object? I mean, why can't we just let the AI generate whatever text it wants? It's a great question. And the answer comes down to two words: safety and predictability. This DTO, it acts as a super strict contract. We are telling the AI, hey, you can only respond in this exact JSON format, no exceptions. This is what prevents it from generating random text, or even worse, malicious SQL that could lead to huge vulnerabilities like SQL injection. Think of this DTO as our guardrail. It's absolutely crucial. So if you look inside the DTO, you'll see these three key fields: op, field, and value. Together, they create a simple, structured language for our filters. For example, the field named GPA should have an op, or operation, of greater than with a value of 3.5. See how that works? What's really cool is we can even nest these to create complex and/or logic. This simple structure becomes the language our entire system will speak. Next up, let's talk about our repository. Now look closely, because this small piece of code is actually incredibly powerful. Most of us who've worked with Spring know JPA repository, right? It gives you all the basic CRUD operations. But the secret sauce here is extending JPA specification executor. By adding that one interface, we unlock the ability to build complex dynamic queries programmatically. This is the key that lets us use our nice JSON DTO to actually talk to the database. Okay, so let's recap where we are. We have a way to get structured JSON from the AI, and we have a repository that can handle dynamic queries. So what's missing? Well, we need the bridge to connect the two. And that bridge, my friends, is our student specification class. Its one and only job in life is to translate that filter request object we get from the AI into a query predicate that Spring Data JPA can actually understand and execute. Okay, and this code right here beautifully illustrates the concept. The build predicate method, this is the heart of our translator. We're using a switch statement to look at the op field from our DTO. Then, and this is the important part, we use the JPA Criteria API, which is a programmatic and, really importantly, a type-safe way to build queries to construct the correct predicate, like CB equal or CB greater than. This is how we safely build that final where clause without ever resorting to risky string concatenation. All right, so we've built this entire pipeline for handling the JSON once we have it, but where does the JSON actually come from? I mean, how do we convince a powerful large language model like Gemini to create this very specific structure for us? This
is where prompt engineering comes in. And honestly, here's where things get really interesting. We give Gemini a very specific set of instructions, what we call a system prompt. We literally tell it, you are a specialized API assistant. We give it a list of the exact database fields it's allowed to use, the operators it can choose from, and we even give it an example to follow. We are essentially teaching the AI how to use our API correctly.
So the Gemini agent service is the class that handles this whole process. It takes the user's plain English question, wraps it up inside our detailed system prompt, and then shoots it off to the Gemini API using Spring's web client. When the response comes back, it's just JSON text, so our service parses it and deserializes it directly into our filter request DTO. It's the orchestrator of the whole AI interaction. Okay, we did it. We've built all the components, the architecture is solid, the code is all in place, so now let's put it all together and see our little agent in action.
So to test this on your local machine, you're first going to need to authenticate with Google Cloud. It's a really simple three-step process right in your terminal. First, you'll log in with gcloud auth login. Second, you'll set your active project. And third, you'll run gcloud auth print access token to generate a temporary token that you can just copy and paste into your application properties file.
Okay. Now, a really important warning here. Seriously, this token expires pretty quickly, usually in about an hour. It is perfect for local testing, but please, it is absolutely not for production. The right way, the good way, is to use a Google Cloud Service account with something called Application Default Credentials, or ADC. Basically, ADC automatically and securely finds and uses service account credentials without you ever needing to manage keys or tokens. It's the robust, secure choice for any real environment. All right, this is it, the moment of truth. Let's run a test. So with our Spring Boot application up and running, we can pop open a terminal and use this curl command. We're sending a post request to our API/students/ask endpoint. And the body of the request is just our simple natural language question. Let's see what happens. And there it is. It worked. Success. The application returns a perfect JSON array containing the two students who match our criteria, John Doe and Sarah Connor. The entire end-to-end flow, it worked flawlessly. So let's just quickly recap the powerful pattern we've just built. It starts with plain user input. That goes through some clever prompt engineering to get structured JSON output from the LLM. That JSON is then translated by a JPA specification into a safe, dynamic database query. Simple, clean, and powerful. Now, why is this pattern so powerful? Well, it's because it gives you the best of both worlds. You get all the amazing flexibility of natural language from a large language model, but you combine it with the rock-solid safety and predictability of a strict API contract using that DTO. You can use this for all sorts of things, reporting dashboards, dynamic admin panels, or search bars that feel, well, magical to your users. Think about it, we're no longer forcing our users to learn complex filter menus or weird query languages. We're just letting them ask for what they want. This simple but really powerful pattern opens up a whole new world of intuitive user interfaces. So the only question left is, what will you build with it? For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.